Hello friends, welcome again. Today we'll be solving a problem related to DC machine, and the problem is a 200 volt DC series motor is given which is running at 1000 rpm and it takes 20 amps current. Okay, and the combined resistance of the armature and the field is also given, which is 0.4 ohms, and the torque varies a square of speed, and so the resistance to be inserted in series so that the speed reduces to 600 rpm. Okay, now we know that for any DC machine, torque is proportional to the product of flux and armature current, and the back EMF is proportional to the flux and speed. Okay, n is the speed and phi f is the field flux. Okay, so the product of the two is proportional to EB. But for a DC series motor, as you can see here, the field winding, this coil shows the field winding is in series with the armature, hence the flux is proportional to the armature current, hence the torque becomes proportional to I squared. Okay, this means the armature current square, and EB becomes proportional to IA into N. Okay, the product of current and the speed of the machine. Okay, so let's proceed now. Let us say that our torque before inserting resistance was tau 1. Okay, so that would be proportional to IA1. Okay, whole squared, and say after inserting the uh, external resistance, torque becomes tau 2, so it will be proportional to IA2 squared. Okay, okay, so from here you can see that if I take the ratio tau 1 over tau 2, it becomes equals to IA1 squared over IA2 squared. Okay, so this is one relation, I put it as 1. Now again you can see that the torque varies the square of speed. Okay, now so for the torque tau 1, at that time say the speed was n1, so the tau 1 was proportional to n1 squared. Okay, and also after inserting the resistance, say the torque tau 2, and it will be proportional to n2 square, which is the speed at that time. Okay, so you can again write a relation like tau 1 over tau 2 is equal to n1 squared over n2 squared. Okay, means the previous speed over the speed after inserting the resistance. Okay, so now you can see that you can equate 1 and 2. Okay, so I can write combining. Okay, 1 and 2, so we can write tau 1 over tau 2 is equal to ia1 squared over ia2 squared is equal to n1 squared over n2 squared. Okay, which implies that ia1 squared over ia2 squared is equal to n1 squared over n2 squared. Okay, now this further implies that ia1 over ia2 is equal to n1 over n2. Okay, n1 over n2. Okay, now let me write it again. ia1 over ia2 is equal to n1 over n2. So this is what we have got. Now you can see here that the only unknown here is ia2, which is the current that will flow after inserting the resistance. So let us find it out. So if I write ia2 here, that will be equals to ia1 into n2 over n1. Okay, now you know that n2 has to be made equal to 600 rpm. Okay, and n1 is 1000 rpm. Okay, so this information we know, and ia1 is also known to us, that is equal to 20 amps. So when we can put all these values and we get ia2 as 12 amps. Okay, so when you put all these values you get ia2 as 12 amps. So now we have our current ia2 from here. Now let us write the back EMF equation for the case before inserting the resistance. Okay, so now before inserting R external, okay, this is before inserting R external, the equivalent diagram can be shown like this. Okay, okay, this is the equivalent diagram. Now what you can do here is you can write the KVL. So KVL is V equals to, okay, ia1 into R, okay, plus eb1. So R is the resistance of the armature plus the field, which is 0.4, so R is 0.4 ohms. Okay, so now from here you know that V is also given to us. This is 200 volts. So 200 volt is equal to I. IA1 is 20 into 0.4 plus EB1. Now you can say that EB1 is equal to, if you calculate all this, it comes out to be 192 volts. Okay, now you have your EB1. Okay, now say after inserting the resistance, okay, after inserting the resistance, you have back EM as EB2. So what we can do is we can again find EB2. Okay, and from there again we have a relation, and from there we can calculate our R external. Okay, so now before that let us now see what EB1 is proportional to. Okay, so EB1 is proportional to IA1 N1. Okay, this is before, I will write it before, and after, let's say it is EB2, so with that will be proportional to IA2 into N2. Okay, so now you can write it as EB1 over EB2 is equal to IA1 N1 over IA2 N2. You can see here that you know everything except EB2 here. Okay, how? You know EB1, okay, just now we calculated, it is 192. IA1, okay, it's known, N1 is known, N2 is known, IA2 we have just calculated it as 12 amps. So you can calculate EB2 from here. Okay, if you calculate EB2 from here, that comes out to be 69.12 volts. Okay, so now we have with us EB2 also. So EB2 is also known to us now. Now what we can do? We can now take the case where the R external is also present, and this EB2 is now known, 69.12 volts. IA2 is known to us, which is 12 amps. So only thing is which is unknown is R external. So let us write KVL after R external inserted. So if you do that, what you get is V is equal to IA2 into R plus R external, okay, plus EB2. Okay, now you can write all the knowns that are there. So this is 200 volts, and this is IA2, which is 12 amps, which as we calculated earlier, and this R resistance is 0.4. Okay, and R external is not known to us, plus EB2 is known to us, which is 69.12. Okay, now from here you can further simplify it, and you can write it as 12 into 0.4 plus 12 into R external plus 69.12. Now if you calculate R external from here, because it's a simple equation, it comes out to be 10.50 ohms. Okay, so this is the resistance which should be inserted in series with the armature, so that you get the speed and equals to 600 rpm. Okay, so this is how you need to solve all the problems, okay, related to inserting the resistance in series with a DC machine. Okay, so thanks for watching.